Hello everybody and welcome to Conics 7. And so we have two questions here, an elliptical one and a circles in contact one question. Now, in relation to the elliptical question, you have the major axis, you have the minor there, so I'm not going to draw on the ellipse, okay? Now one tip I would give you, if you find it strange drawing an ellipse upright, I would get my sheet, turn it around and then draw it, okay? And then when you've finished drawing, you can turn it back again. Now the only thing I wanted to have a look at here, this is a mirror stand, okay? And in the stand, we have an arc of a circle here, okay? Now you have points 1, 2, and 3. Now we know that the center of that arc must be somewhere down along that line there, okay? But where is it exactly? So when you have something like this, now if you knew the radius, you could just swing the radius from points 1 and 3 and that would find you where to put it, but we don't have the radius. So if you go back and remember, if we draw a line from 2 to 3, that would be a chord on part of that big circle, okay? Even though we won't be drawing the full circle eventually, it would be a chord, okay? So it's a line from one point on the circumference to another. And what you do is you bisect that line there, okay? So get your compass, extend it slightly more than halfway, and we'll bisect it. Now we know it's somewhere on this line because it's symmetrical distance from here to here. So you can draw the bisector, extend on the bisector, and where the bisector hits the line coming down, we call that point X. That is the place to put your compass now. Set there. And we're going to draw in our arc like so. And that is how you go about solving that part of the stand. The rest of the ellipse should be no problem to you. As I said though, turn it around if you need to. Now we'll go on here and I'm going to draw out this solution to this question, which is a simple enough one. It's an egg cup, okay? I've drawn the top line, I've drawn the bottom line, and we know the distance in between it there is 75, okay? So we have a couple of partial circles in contact, okay? First one down here is radius 14. So set your compass there. And we'll just lightly draw in that circle for the time being, and same over here on the left hand side. Now, that's radius 14. We know that that is coming in contact with part of a circle that would be radius 68. And we know from our theory before, if we have two circles, no matter what size they are, the distance between them is the radii added, okay? So, therefore, 68 plus 14 equals 82, okay? Now, where am I going to go and draw this, you might ask, okay? Where do I do my swinging from? Well, we know from that piece of theory there that the center of this radii 68 arc must be 82 millimeters away. Why? Because I'm reading the radii. So set your compass there to 82. Put your metal down in the center there, and we're going to swing an arc there. And we're going to do the same the other side. Now, we also know we have this point. This is a point on the circle. We'll call this S over here, and we'll call this guy T. So we'll just worry about the right hand side first. So for the arc coming in here, the center of the circle is somewhere on that there, radius 82 from there. The other point I know is this point T, and I know T is 68 millimeters to the center of the circle. So you can pick any point on a circle, and it's always going to be the radius to the distance of the radius to the edge or to the center, okay? So if I put my compass down there now on T and I swing an arc, it's going to find me the point X that I'm looking for. Now I can leave my compass at 68, and I should be able to swing an arc which is going to touch this circle perfectly and come up there to T. Okay. Now we'll finish out that heavier. You can do the same with the other one. S must be 68 to the center of the circle for this side. And you can draw in your arc there on the egg cup there. Okay, and then we'll just finish out these heavy. And that is your egg cup drawn. Okay, so this guy, part of a bigger circle, this part of a smaller circle, but the distance between the two is 82 millimeters. And if you ever wanted to find the exact point where they touch, you would just draw a line from the center of one circle to the other. That is exactly the point at which they touch, in case you're asked that for. Okay, so I might just, before I finish, I'm just going to make that guy bigger just to help us with the visualization process of that is part of two circles in contact. Okay, you don't have to put that in, I'm just doing it for demonstration purposes. But so that's it, folks. Circles in contact and our elliptical friend here. And remember, just to, when you're doing this question down here, bisect join a line from 2 to 3, bisect it, and where the bisector hits the line coming down, that'll find you X. That's it, folks. More videos to come. Take care and stay safe.